little bit of late start. I didn't want to come back is the problem. All right. Okay, unfortunately, we have about a full hour of stuff. Although I certainly want to answer some questions if you have some. I guess any questions in general? We're okay. And a question?
I have a question about true or false question number 7 under test.
That's on my list.
I have no problem, well, my problem is not part A, which is the false, but with part B. Could you go over part B? I'm having a lot of trouble dealing with these functions and natural variables and less than zero spontaneous.
Right, I'm covering that.
Okay.
That's on the list, but, seriously, look out. So, okay, I'll go just a little bit out of order here, and because I was going to have one or two more before number 7, but that's okay, doesn't matter. I can do it, should have brought a copy of the test. That's the one that says that delta A is less than 0, is spontaneous at constant T and V. Is that part A?
Look at what it says on the table.
It says,
Well, this is an old test. It's the first test. Okay, number 7 is, it's pointless to consider Gibbs energy changing with G. Right, is that the one we're talking about?
yeah, I'm more interested in part B.
You got that one right. I remember things really well, by the way. That's okay. All right, so the part 1 was, it's pointless to consider how Gibbs energy changes with temperature, since delta G is only relevant when temperature is constant. That's the false one. The next part is the changes in the four energy functions, like U, H, A, G, are important when the natural variables are held constant because they're minus T times total entropy, which is true. All right, so let's just do that one. Okay, so I was a bit upset that, you folks, this is one of the ones that was hugely missed, as well as number 4, I believe, which, number 4, which is almost the same. So I'm going to do 4 and 2 at the same time. And number 4 was, because they're almost the same question, it's a bit of a screw up on my part. Number 4 was if A is, if volume and temperature is constant, A less than 0 means the process is spontaneous. Now there's another example of answers to questions and other questions. So I point out that A, which is a function of T and V, if it's less than 0, if those are constant, then it's less than 0 spontaneous. That's because it is minus the temperature times total entropy. So those were related. And that one, number 4 was a bit of a trick question. Anyway, let's do number 7. Okay, so remember, this is the Clausius inequality. So this is one of the ones that you might want to go back on the video. And the Clausius inequality is this. So I bring Q over T over, and I'll just do that. And this is greater than or equal to, because this is not necessarily reversible. If it was reversible, that's when the equality kicks in. So to answer number 4 and 7 simultaneously, hold V constant. Sorry, something's wrong with the handwriting. Hold V constant, and that means that that heat is the change in U. We've done that a bazillion times, so I'm not going to say any more of that. Then note that this is also the change. Again, for the reasons that we stipulated, this is the system, and that's the surroundings, because the surroundings entropy is only affected by the heat transfer. And if you gain dQ to the system, then minus that is what was happening to the surroundings. So this is entropy of the system plus entropy of the surroundings. Just don't let the minus sign fool you. So this is total entropy. Now you multiply by minus T. So that's where, in that one of the, again, the true and false questions, I say that, on number 7, I say that the energy functions with their constants, with their natural variables constant is minus T times total entropy, because that's what I did. This is completely true. So this is change in U minus T delta S. Okay, so I've stipulated one thing constant, and that was U. Now, if I'm going to hold S constant, that means that the change, if I hold S constant, the constant S, the changing, right, I multiply by a negative sign. If 4 is greater than 0, then minus 4 is less than 0. That's how I get that. I'm confused if I ever do that. Okay, U is a function of S and V, and in this derivation I held them constant. And at no point is this not different than delta S total times minus T. That's what it started. I monkeyed with it by multiplying it by minus T. Okay, that's a little bit bad, and that's why your change in U is negative and not positive. Total entropy has to increase, but when I multiply by minus T, then minus T delta S total has to decrease. Okay, now let's say we didn't do this. And let's do number 4, because a lot of you missed that, because it's really the same question. And of all the ways to express these changes, you know that there's 2 ways to do this, and some of them are better than others, and this is the one that works best. And it's just, I happen to know that, and that's just the kind of thing that unfortunately you are faced with being tested on. And why, when I realize that, I try to give you the first step, because I know what the easy way to go is. Okay, so now I've got the change in U minus the T change in S. Okay, if I just subtract S dt and then add it back, then I added 0. But this happens to be the change in A plus S dt. Then, hold T constant. Now I've got the change in A. Change in A is less than equal to 0. Okay, so now the point here is, I've done 2 variables. It wouldn't be particularly hard to do G and H. I won't do them because it's kind of irrelevant. You make different stipulations. For H, I would hold P constant. And if I hold P constant, then heat becomes the change in H, not the change in U. And then I would have held S constant, because I would have had dH minus T delta S. And then I hold S constant. And if I was doing G, I think you did that on your homework. It's certainly complicated. There's a lot of terms, but again, it's not really an issue. So again, I was a bit taken aback. I never had a class. This is a question of variant. Don't ask the same questions, but I have to ask variance of questions. So this was slightly reworded from last year, but not fundamentally different. And everyone got that question. And this variant, you didn't. And I just was a bit taken aback by that. I really don't know why. Now remember, so what you had done wrong was you had all said, for again number 4, and then again it came up on number 7, minus PdV. You went this route. Okay, you said, well, if V and T are constant, A is 0. Okay, if that's what you missed, and that's a good percentage of you, don't forget that this got brought up in class. One of you actually directly asked this question in class. You're like, wait a minute, why aren't they all just 0? Because there's extra terms. Remember this? I told you that this was actually the reason why. So, look, there's other things. I've been sticking with gases. There's rubber bands, there's screwdrivers that can be wound up. Rubber bands can be stretched. They have changes in tension. They have tension times change in length. That's like this. So instead of this, if this was a rubber band, this would be tension times change in length. So there's lots of other possible terms here. I have just kept it simple by sticking with gas in the balloon. So anyway, again, if you were the person who missed that question, I think the solution is watch the videos. I know that is roughly 12 hours of videos per test. Well, now you know what you're doing next Sunday. I know that kind of blows, but you can do it. So anyway, there's my answer there. We okay? Yeah. All right. In the interest of time, let me Okay, let me give you another example. If you missed the first question on true and false, the source of entropy is how fast molecule motion randomizes. Watch the videos. That was there. We talked about that. And that was that gas, liquids, and solids, when work, which is coherent motion, randomizes in a gas in 10 to the minus 9 seconds. Again, so fast you can't even remotely perceive it. You perceive things on about a 10 to the minus 6 time scale, and this is 10 to the minus 9. Solids, if you hammer something and all of those atoms are moving in the same direction, they do so for 10 to the minus 13 seconds. Right, so even faster. Let's see, so I covered number 4, number 7. Okay, the biggest loser, number 4. Number 4, not true false, but we actually. Okay, number 4, I said delta S is, and I know that this was not worded well. I got real lost on this. And don't even write this down. You don't really need to write any of this down, especially if you got it right. But again, you're getting inside my head. I'm telling you how I thought of this stuff. And that's probably pretty valuable to be heard for the class, because I'm writing the next 2 tests. All right, the question was, why can you apply this to any situation? Adiabatic reversible, adiabatic irreversible, isothermal, blah, blah, blah. Why does it always work? You all trying to say, well, if it's isothermal, then this is 0. If it's adiabatic, then this. When did you actually prove that for adiabatic conditions that this was 0, which had nothing to do with anything? Kind of. I mean, if you worked a lot of things with this, I tried to give 2 or 3 points partial credit, which is what most everyone got. But 2 things was, how did you misinterpret it? And of course, to some degree, how did I not write it well? Was that the question is, why does it always work? And how I should have worded it better would be, why is this equation the same in every condition? Why is it always the same? And again, yeah, if it's isothermal and this is 0, then that's fine. It should be 0. So it still works. It just has to be 0. There's nothing wrong with that. So I should have said, why is this the equation for every condition? So, because you can imagine, yeah, this is correct. You're going to use all of these for adiabatic irreversible. But who says that in isothermal irreversible that delta S was a horse and a chicken? Right? So in other words, why is the equation always the same? Next thing you didn't do. I said in class during the first 10 minutes where I ran my mouth about the test, I said this was an answer in words question. Right, now here's another hint. I said this is the equation for all conditions y, question mark. If I do that, I mean answer in words. And I said that. Okay. I should have written that on the test. That's another mistake on my part. Let's see, I'm faultless here. Many of you got another hint. A lot of you did so many derivations. Why is that number 4? Why is that the first non-true and false question then? Why would you do tons of derivation on the first non-true and false question? 3 words, that's the answer. Right. Delta S is exact. It's path independent, therefore it applies no matter what the change is or how the change is done. That means reversible or irreversible. So, okay, I think you got something out of that, and I got something out of that about writing better questions. And I will hopefully not express it that way again in such a way that I trip all of you up. There were some minor details on 6 and 7. Number 6 was the AdV, a constant V. The AdT, a constant V, is minus entropy. Is terribly simple. But I did take off a point on most people's because I need you to tell me that S is always positive, right? Why did you say, it says, how does A change with T? I'm looking for you to spit out something trivially simple, but I can't give you credit if you didn't spit it out, that if T goes up, A goes down because S is always positive, and therefore minus S is always negative. You don't need to say that, I understand that at that point. So a lot of you didn't put that down there, and that was the question. Even though I know that getting to DADT, a constant V is minus S, that is most of the question, but it doesn't fully answer it. And I want you to know that S is always positive. Same thing on number 7. Okay, describe the VDT, a constant S. That one really set me off because some of you said, well, the change in volume with temperature, a constant entropy, is equal to minus the heat capacity, a constant volume divided by pressure. Oh my God, I am not asking you whether you know that P means pressure. Right? That's for the 5th grade. You should know that. I'm not going to ask something that stupid. All right? And I even said in there, like, Tell me, I tried to poke you in the right direction in terms of being descriptive. Constant S, adiabatic reversible, right? S is only constant for adiabatic reversible. Yeah. Oh, what about isothermal reversible? No, S can still change. It's just the total S that doesn't change. Only adiabatic reversible has S equal as S constant. So I wanted to see that. I wanted to see that you knew that CV and P's are always positive. Therefore, the change is negative. Why did it make sense? I asked, why did it make sense? Because the system is insulated. Right? See, I'm not saying P is pressure. I'm telling you really what is this thing. It's adiabatic, therefore it's insulated. That's why when I compress, I know that compressing a gas causes it to get hot. Remember I told you about how Survivor Man has that fire starter, which is a wood block and a plunger, and he puts little tinder at the bottom of it, and then he has the plunger, and he just pops it as hard as he can. Actually liquefies air. You are strong enough to liquefy air, and that liquid air is very hot, and then the plunger pops out, and the tender's on fire. So you know that. That's what I was looking for. Okay, let's see, what's a good one? For the Euler chain one on number 12, some of you did not use Euler's chain. I gave you a lot of partial credit to solve that. But I swear to God, if I'm asking you to, the point of this question was that there are multiple ways to answer things, and it was a very easy question. So a double win in my perspective, but some of you answered it the way I answered it in class. I gave a lot of credit, but I didn't give full credit because you're not doing what I asked. And I don't feel like being, I don't like being a dictator at times, but hell, I mean, that's what I needed you to do. Okay, the next biggest thing, this was the big one. Now most of you, almost all of you got this right, about maybe 1/5 of you did this, but it's very instructive. And so I didn't want anyone to make a mistake, but it's just that you guys are actually such a deep class, deeper than anyone else have ever had. You think of things which are really clever, but can be wrong. And I didn't adequately prepare you for some of these things because I just didn't. It's like you come up with new ways to make mistakes that actually mean you're pretty bright, to be perfectly honest, it's true. And so this was the question, and then it was, how does S change with V, which is it's really surprising. It's like seeing big CP natural log VF over VI. That was a very strange result, but because it's not the standard equation. I'm not sure why it came out that way. I'm still trying to figure that out, but anyway, let's do it. Okay, this ends up being dt, dV, constant P, Cp over T. Now, what I was hoping for was that, is that right? Yeah, okay. And then, let's see, dt. So, I always have trouble with T, dV over nR. Okay, so, P over nR. nRT Cp, which is Cp over V, and then ds is Cp over V dV, and that is the answer. Now here's where some of you sidetracked. Let's start here. And this is very instructive, by the way. If you got it right, that's fine, but let me show you something that's really kind of cool, which ends up being correct but for a weird reason. When people did this part, they rewrote it like this. And I even was very flummoxed by this, what the hell was happening. And then the delta S ends up being Cp ln Tf over Ti. Now here's the clever thing. I gave you full credit because this is actually technically correct, but for a very weird reason. Doing it this way is extremely dangerous. But it was correct. What I gave full credit on, because of the nature of the question, because I gave you the answer, was realizing that for a perfect gas, temperature and volume are perfectly in line. Boyle's law, whatever the heck it is. And the reason that worked is, so these are totally equal. So that I ended up giving full credit once I thought about it enough. Okay, what was the danger? Sorry, let me back up. Why did it work? Because of this. That's why that action became legal. If this wasn't true, if these were different letters, it had V and P, then you cannot do this step. That does not work because it's unknown what's held constant, and that can result in well, sorry, for dV over dV, it doesn't matter, it's held constant. But the problem is that it's not clear if these are not the same, what should be held constant. That means you can't do it. And to prove that, it's Euler's chain proves it. And I don't expect you to memorize it, but remember there's a pattern. There's a clear pattern in this. This one, that one. The X and Y. And the thing is that it looks like this cancels, and this cancels, and I'm left with dx over dx, which should be 1, but it's not, it's minus 1. And I think I might have proved Euler's chain. If I didn't, it's an easy proof to derive this. Very, very simple. And the reason is that you can't cancel these. You can't because different things are held constant. It's not valid to do that. And that's why instead of 1, you get a minus 1. So anyway, that's the thing that got you there. And I guess I had some other things, but I really do need to get to the homework questions. So we're okay? Sorry, I really need to get to the homework questions. Because you have not seen partial volumes before. And then I'm going to work a problem for a gas as A goes to 2B. And I'm going to figure out what alpha is, and I'm going to walk you through how to calculate, how to prove Lechatelier's principle. Okay. Now, partial volume, you always got to work with this equation. Right. Total volume is the integral 0 to NA, and here's the partial volume. And I'll always stick with 2 things because, why not? I'm not sure if it's doable to do 3 things at once. Besides, not many people do that anyway. And remember that the partial volume is how does the total volume change with the addition of n sub A. And again, we're in a constant pressure temperature world just because we're going to make things easier. And NB, whatever B is held constant. Okay, now, first thing to note is that because, again, I want to make sure that you've had the same exposure as everyone else. That sounds a little generic, but it's not. It's relevant if you have a test, you have a GRE. These are often replaced with mass instead of moles. And your partials are then dV/dG, G being grams, not dV/dN, N being moles. So when I looked at the example problems from the book and online, I found many examples where this was done in mass, not moles. So I threw that at you too. So now the question is, I have a 50-50 by mass, that's important, solution. This is very similar to one of your homework. The density is 1.5 grams per milliliter, which is really high, it's unusual. There are plenty of chlorinated hydrocarbons that do that, tend to be pretty heavy. There's the density, and the A is 0.7 milliliters. Okay, this is a gram one, and I'll do a molar one. So, what's dV? Okay. First step is you often see densities, and you saw a little bit of this with perfect gas. Make a decision. Decide how many mils there are. And then it also gives you mass. So 1, decide you have 100 milliliters. And therefore, you have 150 grams of solution. Okay? Number 2 is use this equation. Okay, that's total volume. I just decided to be 100 milliliters. Okay, let's do A. Okay, so V sub A times this will be integrating this V sub A times the number of moles of A, but I'm doing this in grams, so this is going to be V sub A times the number of grams. Now I already know how many grams. 50-50 by mass, and I have 50 grams total. That means I have 75 grams of A and 75 grams of B. Okay, so now, again, because I've done this in grams, not moles, I'll do it in a different one. So I have 75 grams times 0.7 milliliters. And that works, right? So now I've got mils and mils. Plus 75 grams of B times X. I don't know what X is. Okay? It was incredibly easy. What's the answer? or just so you, 0.63 repeated mils per gram. You see, it's actually very trivial. All right, now, let's do a much, much, much harder one, and let's do that one in moles. It's actually the same question. I've converted it to a mole question. I've converted the nature of the equation. See, some of you let me talk this up really quick. This is some still writing. Sorry. To finish that, I'll bring to the board. So if you're clever, you'll notice that I'm actually going to ask the same question, but I've made it much harder in this next example. So you have two partial molar questions. Each one that I'm doing is very, very similar to the one that I asked. Let's see, the question. You've got a liquid with a density of 1.5 grams per milliliter, just like before. And it's made of corn syrup. So A is corn syrup. And it has 180 grams per mil. Corn syrup is very dense. And the partial of A is 126 milliliters per mole. Okay, so now I've converted to moles. B is sulfuric acid, and that has a 98.1 gram per milliliter. And it's this guy is 62.13 milliliters per mole. The question is percent composition. That's the question. So, sorry for my shorthand. I can't write out the whole thing. It's too painful. So follow along with the video if you're having trouble with your notes. So, all right. So I've given you this information. Now I want the percent composition by mass. Okay, this is kind of painful. So again, decide 100 milliliters equals 150 grams of solution. And number two is then again, use the equation on top. 100 mils. Okay, now I just have to, now I need number of moles times the partial volume. I've got the partial volume. Now I can tell that number of moles is going to be my hard part. Now, and I need percent composition by mass. That will be set. It is set in this question. Okay. Now, all right. So I got this part. Even if I'm confused what I need to multiply by, unconfuse yourself with units. I keep saying that. I need to multiply by number of moles. Moles will be grams by molecular weight. I have the molecular weight. I just need to know the number of grams. I have the total number of grams. I just don't know what percent by mass it is. There you go. That was the question. So percent times, there's our x, 150 grams divided by the mass, which is given to you 180 gram per milliliter, gram per mole. Okay, then basically the same for this, 62.13. I hate writing down units, but it's necessary. Okay, now here's the problem. I can't use x again, they're not the same. Oh, they might be, but that would be pure dumb luck. Right? I need to do 1 minus x percent. So remember, percents, I know 50%. Remember that in mathematics, when you're dealing with percents, you're dealing with 0 to 1. So 1 minus that is this guy, times 150 grams. Okay, this is the grams of feed divided by its molecular mass, 98.1 grams per mole. Okay, now you can solve for x. I won't do it because I need to get to the next question. Oh God, I'm running out of time in a big way. Okay, x actually happens to be 0.5. So it's a 50-50 solution by mass. Now, my point here, when you, if you want to study this a little bit more, and maybe I'll put one of these questions as one of the easy questions on the third test. Maybe I'll do that because I think it's kind of a giveaway. What I value about these questions is it makes you just logically walk through it. there's so many ways to mess with these things, to give you this information and that information, which of course I make sure works, but you have to just, you see how I did this? I just had to think about it. What should I do? What should I do? What should I do? What's logical? So I like that. But I don't really care, you know, who really does this stuff? Who gives a damn? Question?
On top of it, A and B is minus grams per milliliter, and on bottom, these ones grams per mole.
Oh, sorry.
That's supposed to be densities or more than that?
These are molar, yeah, these are molar masses. Now, I've done this right, 126 mils per mole. Now I need number of moles. This number of grams divided by 180 grams per mole.
Zero.
In terms of this, I don't.
Up top, you have A equals 180 grams per milliliter.
And B equals 98.1 grams per milliliter.
Oh, sorry. Yeah, sorry. So it was B. Oh, sorry.
So should A get changed to mole to 180 grams per mole?
It is. Oh, sorry, my handwriting is really bad today. Yeah, it was. Unfortunate that those are kind of the same, right? Okay, anyway, folks, we got to get to the next one. It's terribly important because I basically did this once in class, but it's better seeing more than once because this is a tough one. Where are my notes on this? Okay, let's do 2A goes to B. Okay, this is all I've given you, but I'm also going to say that delta reaction, not G. Okay, so it turns out that this ended up being this. So it's a little bit of a fantasy to imagine that a reaction has a perfectly zero Hess's law result, but just for the hell of it, we're going to do it that way anyway. Okay, now build the table. A to B. Now what I have is, again, I like to just try to be as logical as possible. And remember, the point of this is to do the extent of reaction. It's just logical to go with 2n. It shouldn't really matter. After 2n minus alpha 2n, right? I normally would ask you, but I'm running out of time. Okay. Then, of course, I'm going to gain alpha n of b. Because, 2 to 1, stoichiometry. So don't miss about that. So you have to think about how do you go from 2n to 0. You have to come up with the function yourself. Yeah, I'm not relenting on that. I'm not going to give it to you. I was very nice on the homework, but I won't be on the test. And you've already written that question in my head. Now you do the total. 2n minus alpha 2n, sorry, 2 and alpha look the same, plus alpha n is 2n minus alpha n. Okay, then we get the mole fractions. 2n minus alpha 2n over 2n minus alpha n over 2n minus alpha n. Then simplify it. Let's see, so you just get rid of the n's. 2 minus 2 alpha over 2 minus alpha. And this guy is alpha over 2 minus alpha. Okay, continue over here. Okay, now we got to build K. Set that equal to minus delta G over RT. And then plug in numbers. Let's see, K is going to be the partial pressure of B over the standard pressure. And it has a stoichiometry of 1. I have to flip A, and I have to square it. And so this is going to be B. And And again, it's good as that the units work. Now you insert PA or B. PA or B is the mole fraction of A or B times the total A or B times the total pressure. Okay, so that means that, okay, so let's do B. B is alpha over 2 minus alpha times flip, I'm going to flip A, 2 minus alpha over 2, yeah, I think that's right. 2, I might kind of freak me out. 2 minus 2 alpha. Yeah, okay, sorry, my brain just froze. I'm just going to go ahead and take care of the pressure separately. And it just turns out that I'm going to have one P naught over P. Right. There's a P naught, and so my pressure ends up being below it. I know that these have to be the same, essentially. Just one has a little knot. Now, again, often the questions, if you keep P at 1 bar. So traditionally, this is done in questions like on the GRE. They generally will do this. Now, that may require a magic box that can expand or contract. It looks like it needs to, what have I done? It looks like it needs to contract in this case to do that, which is a strange box, but I guess that's what it does. In which case, it just means that this part goes away.
Shouldn't be there squared on the 8.
That whole thing needs to be squared, doesn't it? Yes, thank you. Just rushing. I hate it when I get into this panic. Okay, now. Okay, so here's the thing. That cancels that. That kind of cancels that. Let me just do one last time. What I'm going to end up with is 2 alpha minus alpha squared. Okay, because one of these gets canceled, so I got alpha times 2 minus alpha, so that's easy. And then I end up with this guy, so this part's gone, so this guy squared will be 4 plus 2 times 2 and 2 of them, so that's 8 minus 8 alpha. And that squared 4 alpha squared. I know I kind of did that backward. Okay, so now this is equal to E, the minus delta G over RT. And this is equal to what? Remember I said delta G was 0? It's equal to 1, right? It's not 0, don't screw that up. Okay, so now, what I've got this guy here. So I'm going to bring this over here. I'm going to start with the 4 alpha, and then plus 4 alpha squared. And then I've got minus alpha squared, so that's 5 alpha squared. Okay. Minus 8 alpha, minus 2 alpha, minus 10 alpha. All right. And then 4 is 4. Okay. Then what you do is, no, I'm not, yeah. All right, yeah, that's right. And so, it looks like I made a mistake, crap. Have I made a mistake?
That's 0.
Yeah, 0. Yeah, sorry, 0. Right, because I subtracted all of this over here. Sorry, guys, just rushing. Okay, now, quadratic equation. Right. So now this guy, you can do on pen and paper. And remember, when you use Wolfram alpha, it's going to give you 2 answers. This is a quadratic equation. It's going to give you 2 answers, so you need to know which one to pick. Only one of them is correct. It's weird how that happens in physical sciences, that our equations sometimes, if we run into a quadratic, gives us 2 answers, but for physical reasons, only one of them is right. Get used to that in quantum. In quantum, that crap happens all the time. We have differential equations. Unfortunately, the Schrodinger equation is a differential equation. There are multiple answers, right? A differential equation can have a family of solutions, but for physical reasons, all of them but one will be ridiculous. like energy is infinity or mass is infinity, but one equation, one answer will always be the right one and it'll make sense. Okay, so I know that B is y is 10, A is 5, C is 4, and the two answers, if we do a plus answer, we get 1.447, and the minus answer ends up being 0.553, which is the right one. This, all right, what am I solving for? Alpha. Alpha goes from what to what?
0 to 1.
Which is the right one? This is the right one. Okay. Again, remember, Wolfram, if you decide to solve this with Mathematica, which I'm okay with because that's why it exists, I just want to remind you, you did learn this in grade school or middle school. And remember that no matter how you do it, you got two answers. Only one of them physically makes sense. But last bit before we're done, I'm sorry I got to go over this. Let's say if P initial 1 bar, P final. So anyway, let me get back to this. So this is the extent of reaction. So it goes over halfway to completion. That's kind of neat. I would have thought I would have stopped halfway because delta G is 0, but no, it's not. It doesn't do half. It goes a little over half, and I think that's because it's in a magic box. And the magic box does some work. It has to compress in this case, and because it compressed a little bit to keep the pressure 1 bar, it actually pushed the reaction a little bit, right? And that makes sense because this is 2A going to B, and the box compressed itself. And I think that helped form more B. It pushed to get rid of A, right, because the box became smaller. It gave a kick to those two gases to turn to one gas, so it favored products. Now let's do it realistically. All right, realistically, the box is a metal box. The pressure is going to drop because you're losing gas. Now, I need to, guys, I'll tell you what I'm talking about, right? So, tell me how I do that. Now, I'm not going to let pressure be 1 bar. It's going to start out at 1 bar, and it's going to go down to what at the end of the reaction? And perfect gas won't play games. What do I do? Tell me where does it end? Starts at 1 bar. I have 2 A's. I end up with 1 B. It ends where? Half a bar. Right. Okay. Now I need to have alpha, and when alpha is 1, I need to have half. So I'm going to shave some pressure off. What do? Again, this will be the nature of the question on your homework and on the test. What do? Alpha's got to be in there. When alpha's 1, this has got to be a half. And when alpha's 0, it's got to be 1. This is really easy. So remember, if alpha's 1, alpha doesn't exist, but this must be a half. What do I subtract from 1 to get a half?
1/2.
1/2, so I subtract 1/2 times what?
Alpha.
Right, alpha over a half. All right, folks, now you've got to figure this out. I'm not going to give this to you on the test. So, and again, this is phenomenological logical thinking. Okay, if I had done that, you go to Wolfram. Okay, and it's on the web, it's on the homework. So you just click it, literally you click on it in the homework. What you've got to solve is 2 alpha minus alpha squared over 4 minus 8 alpha plus 4 alpha squared. Okay? Now before this was all, and now I've got 1 over because of the pressure, because of this right here. Now this is still 1 bar, but now I've got this thing right here. 1 minus alpha over 2. Now to solve it in Wolfram alpha, I'm going to subtract 1 and equal 0. So I actually did I didn't do any multiplication. I just brought this over here, and now it's equal to 0. So you plug this into Wolfram alpha, and it gives you, actually in this case, only 1 solution. Alpha's a half. Double check it. It's true. If alpha's a half, this turns out to be 1. So, I also give you examples of how to work Wolfram Alpha in the homework set, so you won't have any problems. Literally, it just will only wants to see the letter X, so just type X where this is, you get equals. It's going to give you a ton of stuff, but one of them, it says solution, alpha is a half. And here's the neat thing. When we think of delta G being 0 as the halfway point, it is, as long as it's not in a magic box. And also notice the truth of the Sheffield principle. When you lose pressure, the system fights back by creating more gas by not letting two A's turn to one B. It's better to keep your A's around to keep your pressure high. And so it did that. It backed off on letting A turn to B. And we also preserve our notion that a delta G of 0 should mean half and half. Which is right, as long as you don't put it in a magic box. Okay, see you all in a meeting. If you have any questions,